First of all, I would like to thank Durga for accepting the invitation to speak at this event. Durga Malladi is a Senior Vice President and General Manager for 5G at Qualcomm. He joined Qualcomm in 1998 as a senior engineer. Over the past 22 years, Durga has worked on 3G, 4G, and 5G technologies in various technical and business leadership roles that have immensely helped position Qualcomm as a world-class leader in telecommunications. Durga holds a B.Tech from the prestigious Indian Institute of Technology and an MS and a Ph.D. from our own UCLA School of Engineering. He's a member of IEEE and holds 505 US patents. In Qualcomm, he drives the overall 5G roadmap and solutions across business units spanning mobile, industrial, and automotive segments. He's also responsible for establishing commercial engagements with ecosystem partners. It is always refreshing to hear his thoughts on the latest wireless technology outlook. It is my honor and pleasure to introduce Durga to this exciting session.
All right. Thanks, Manar. Hopefully you can hear me well. Uh, it's nice to actually have this talk. Always good to give a talk at UCLA, and this is it's been a pleasure. What I would like to do in the next it's a 1 hour talk, but really I want to keep it as interactive as possible. So I'm going to be spending maybe just about half hour going into uh, covering what probably is relevant for 5G for this audience, and going a little bit into the technology where I believe that it's going to make a big impact in the businesses. We're already beginning to see that, and how we project this technology moving forward over the next 10 years. So, and after that, really, the gist of it is that once you have this sort of a background, I'm really looking forward to all the questions that come in right after that. So let me get started. Um, This is, 5G is the 5th generation of cellular technologies. I'm not going to go into the history lessons, but the very first generational change, going from the initial analog devices that used to be there about 40 years back, very voice-centric technology. The main transition going from 1G to 2G was all about just going from analog to digital. It made the voice calls better. You could actually have a higher capacity, more users could actually use the voice calls, and you could get to the point where the primitive text messaging services could start coming, and that's where things were in the early 90s. And but there was something else that was going on, if you recall, in the early 90s, associated with wireline technology, and that was the transformation of, or rather the introduction of the internet-based services in the wireline space. So you could be on your desktop or your eventually into your laptops and connect to the internet. And the question was, can you just do that wirelessly? Can you do that on your cell phone, going beyond just text messaging? So that was the transition from 2G to 3G, where mobile data, for the first time, you could use your phone to do other things than just voice and text. Email started coming in the initial beginnings of the BlackBerry phase, if you will. 4G was a transition from 3G by taking it to a completely different level, and it was the first time that we brought in an all IP network into wireless technologies. It was given in wireline, but it really made it indistinguishable between wireless and wireline. And today we talk in terms of multiples of hundreds of megabits per second, if not gigabits per second peak data rates. And the concept of mobile broadband with browsing, video streaming, video calls, but more importantly, the explosion of the overall app store and app-based services became mainstream with 4G. So we've had a long history of, every transition actually brings in new services. So it's a natural question to ask, well, what else are we doing with 5G? Is it more G, whatever that means, higher data rates and so on, or what else do we actually have in 5G? So I'm here to really talk about that 5G is a lot more than a technology that is intended for smartphones. If there's one takeaway that you should have by the end of this talk is, if you think that 5G is just for smartphones, wrong. That is not what it is meant to be, at least. It's meant to actually impact a larger, much broader cross-section of verticals. Okay, By the way, I've been in Qualcomm for, this is my 23rd year in Qualcomm. So I've given plenty of presentations over my career over here. And if there is one thing that I can definitely say is that the quality of PowerPoint presentations has improved with every generation. That's very clear in my opinion. So this slide, for example, instead of showing KPIs and numbers and so on, this actually kind of encapsulates all the services that we envision are going to be enabled because of 5G. In that sense, we see 5G as a platform really for the future. But one of the things that you notice in this picture is that it's a little hard to actually see where is a smartphone over here. You seem to have lots of other things, but where is a smartphone? I'll get to that. Just hold that thought. But on one hand, at the top section, you see something that says multi-gigabit speeds. Of course, we're going to keep increasing the data rates. Why? Well, there's a lot more services that still rely upon these extremely high data rates, but it's probably not the high data rates that you can get once in a while that matter. What matters is what's the average data rate that you can get. Imagine the following. You're walking around in downtown San Francisco, and on an average, you're getting 200, 300 megabits per second. Okay, that's like on an average. It's not the peak data rate. The peak data rate could be like 5 to 10 gigabits per second. But if your average data rates are that high, it completely transforms the way that you actually end up using the device. Maybe it's a smartphone, but even that smartphone, when you have such a high data rates on an average, it completely transforms the way that you're looking at it. You don't need those data rates to just watch video. There's a lot more that you can do with that. So we're going to continue doing that with multi-gigabit speeds. But for the first time with 5G, remember, we are talking of applications that go beyond smartphones. We're bringing in two other KPIs. One is latency, and the other is reliability. Let's kind of think through that a little bit further. We associate latency with the responsiveness of the system. Maybe you're browsing the web and you click on something and it takes a little bit of time, you maybe 3 or 4 seconds, and then the web page loads up. Well, what if it was a sub-millisecond latency? That means you click on something and it's almost as if instantaneously it comes up, whatever it is that you're looking for. Maybe you're trying to control an industrial motor. You send a command, and now we are talking of industrial IoT in a factory floor. You actually send a command to a machine, and the latency is in the order of just hundreds of microseconds. All of a sudden, you can actually think of doing that wirelessly instead of using wireline communications. That's what ultra low latency is all about. Why did we pick 1 millisecond? To be honest, why not? 1 millisecond is as good as any. We draw a line in the sand. And typically in these kinds of technologies, you can't really predict everything in the future anyway. So what you rather do is draw a line in the sand and say, we're going to build the technology and they will come. The applications, the services will be built on top of it. None of us have a clear crystal ball into how things are going to pan out, but it does help to rely upon the rest of the ecosystem to build the services on top of capabilities that are built into the technology. And that's what ultra low latency is about. And in this example, you see someone is trying to control a drone that is up there. Another extreme is reliability. You know, when you think of something that is sent over a wire, you typically associate that with very high reliability. Of course, it's going to go through, the communication message is going to go through. But if you can get to, you know, losing just 1 in a million packets, 1 in a billion packets, so 10 power minus 6, 10 power minus 9 error rates, that's the extreme reliability. You can start thinking in terms of replacing wires, all the clutter that you see, whether it's in an enterprise or whether it's an automation, factory automation, or any other kind of manufacturing floor. Those wires can be eliminated and you can actually use wireless technology, but keep the same level of reliability. And that's an extreme dimension. It's not so much about the peak data rate. So these are new applications that come in because using wireless, we're able to do the same kind of a function that a wire typically does today. And that's a big deal. When you kind of expand it from there and you take a look at other things that are going on in this picture, you see vehicles that are communicating with each other. And in some instances, they're actually communicating to the traffic lights that are depicted here on the left-hand side of the picture. And now you can start thinking of, okay, what does this do to the overall automotive industry? By the way, this technology is known as V2X, vehicle to everything. In fact, we are doing trials with this as we speak, wherein two vehicles can communicate with each other in addition to communicating with all the roadside infrastructure around them, traffic lights, stop signs, maybe even signs which actually currently statically show speed limits, but that can change over time too. It can improve transfer, it can kind of improve the overall transportation efficiency and assist uh, in autonomous vehicle maneuvering, in addition to what is already being done with just cameras and sensors. So it actually complements wireless communications, complements what can be done with cameras and sensors. So there's a lot of potential over there, but it's not just fiction. There's a lot of testing that's going on as we speak. In that sense, 5G should be seen as a bigger platform for the future. A lot of thought has been put into place to make sure that this is a platform that we can build upon. And 5 years from now, 7 years from now, if a new application comes in, what you don't want to do is say, oh, we wish we had designed this better because you know what, for this application, we need to do something drastically different. No, that's why we are keeping this as a forward compatible technology. So I'll go into some of these use cases a little bit more. Usually, I'm not going to spend a lot of time going into every single nuance on this slide, but from the beginnings, like think of a whiteboard discussion within engineering, leading to a full-blown commercial product which is mature. It takes about 10 years. It's a lot of hard work. A lot of work that probably starts within within the confines of a small team inside a specific company. For us, that's what we did 10 years back. Identify the problem, try to find out what kind of requirements do we need. In some instances, you don't necessarily have a full-blown problem statement yet, but that's okay. You can kind of project the forwards. You can project forward. Start thinking about what are the different elements of the technology that needs to come together. A lot of inventions that go into this, lots of patents, lots of ideas, lots of prototypes. So you have to build the prototype as a proof of concept, because if you don't test it, how do you know it's going to work? So it's not just about design and simulations, but you got to be able to prototype that and showcase this at a demo level, something that says, yeah, this looks like it's feasible using prototypes. Now let's try to commercialize it. Once you get past that, it's not just a single company that does this. Usually there's a bunch of companies that come together, academia, industry, operators, different device makers, infrastructure players come together in a standardization process. Takes a couple of years, 2-3 years to actually put together the very first release of what 5G of any G would look like. And then you have a collaborative environment where there's a bunch of different entities put together, and then they collaborate to showcase the capability of the technology with over-the-edge field trials, and finally we have commercialization. I have my 5G phone here with me, but I can actually remember the time when we first talked about this 10 years back. It takes that much amount of time to get to here. So there's a lot of early research and a lot of investment into technology that takes us to where we are today. And we're still continuing to do that. A question that I thought I should address over here, not that it actually talks about the specific use cases of 5G, is 5G real? And I will get to that point also a little further, but one way of looking at that is, yeah, in fact, there's a lot of networks that have been turned on, a lot of devices that are out there. 200 million handsets are expected to be shipping in 2020. We're actually pretty much on track to get there, spanning what started off with 6 different regions from US and Korea, neck and neck, with US being slightly ahead in terms of when we launched 5G, closely followed by Europe, Australia, and then eventually Japan and China. And now you see that in other parts of the world, including South America, Middle East and Africa, and we're beginning to see semblance of that coming up in Southeast Asia and India. So it's moving really into the mainstream. You can find devices, you can find networks. Close to about 100 mobile operators now have commercial live 5G networks with 40 plus countries, and with different flavors of the technology that have come in. Here's a sampling of the kinds of devices. Now you might have seen most of the devices which are there on the right, on the left-hand side, smartphones from multiple different OEMs. But what's probably even more interesting is the kinds of devices that are coming up that are not just smartphones. For example, there are vehicles that will be coming out there in the commercial domain, which will have embedded 5G modules. You have 5G being used for fixed wireless services in CPEs, the consumer premise equipment, routers, 5G based laptops. I'll talk about that too in a minute. But there's a lot of other kinds of devices that are coming into the picture as well. So there's a very strong pipeline for 5G based devices as we look ahead. Now, just for once, I will talk about one specific technology called millimeter wave. The only reason I want to talk about that over here is not that we want to go into the subtle nuances of beamforming, but really about it is a frequency band which has never really been used for mobile communications. Nobody has ever used it in handheld smartphones. It's been used a lot for fixed wireless, not fixed wireless, but backhaul fixed services for backhaul communication. But the thing is that with 5G millimeter wave, you can get to like multiple gigabit speeds, extremely high data rates. And a natural question someone says is, well, why do I need like 5 gigabits per second to watch a video? It's actually not just about that. It's not just you who's watching the video. There's 100 other users who are probably watching the video at the same time. Can you actually then imagine every video stream is like 5 to 10 megabits per second, and there's like 100 users? That means you need sustained gigabit speeds across the network. And how do you actually get to that? Now imagine if it's 4K video. Well, you can do that now. There are multiple examples given over here, and I'll just quickly go through those. There's one in which we have multi-view streaming. That means you are in a concert, you're watching, you can see the concert, but you're also watching your device. You can actually see the viewpoint of some of your friends who are probably in other parts of the audience. You can actually see it from there. I was there for the opening ceremony of World Cup Rugby last year, courtesy and invite from NTT Docomo. And we did this demo over there. It was pretty fascinating actually to do it that way. You have multiple people in different places somewhere in the stadium, and you actually get to see that. There are 6 different streams coming up in parallel on your smartphone. You can actually click on any one of those, and that specific viewpoint pops up. This is in addition to what you're seeing, and there's a certain social angle associated with that, as well as different people are conversing at the same time while watching these multiple viewpoints. Another one is, today we do video conferencing in enterprises using the equivalent of a telepresence or something of that sort. But what if we were to actually take it to one level beyond that and talk of collaborative workplace? You have your AR glasses. There's another team located in a completely different location. But what that team is doing actually gets projected in real time to what you are actually seeing. So it's nothing but you're working on a piece of the puzzle, but you augment the rest of it based upon what the other team is doing at the other location. Completely changes the way that you actually think in terms of collaborative workplaces beyond just typing and text that you see. In industrial applications, the kind of capacity that is needed is huge, whether it's factory reconfiguration or whether it is 4K video surveillance with probably some local analytics that actually run over there. And finally, when it comes to multiplayer gaming with different kinds of viewpoints, the kind of capacity that you get with millimeter wave is huge. Some of these are very consumer centric, such as multiplayer gaming, the venue connectivity that you have, and what I talked about in that concert with the multi-view streaming. But industrial and enterprise applications specifically cater to vertical segments where they're trying to improve the operational efficiency of the network in itself. In that sense, I want to say something here. 5G should not be seen just as a technology that improves the overall consumer experience, but it's actually a mechanism of improving the operational efficiency in a large number of other vertical industries as well. In that sense, 5G is truly an operational technology. It's not just a consumer technology. Just keep that in mind as you kind of think through. Okay, now I'm going to kind of skip through that by simply saying that given these extremely high data rates, the user experience that I talked about when you have a 5G device versus what you have with 4G is pretty high. When you are in 5G coverage, of course, most people say, well, we don't have enough 5G coverage. That's coming. That's okay. That's coming in the US too. But the user experience when in 5G coverage is significantly better compared to that. It's 5x faster. It's 2 to 4x better in terms of the overall latency reduction and so on. significantly better on an average. Another way of looking at now 5G going beyond just smartphones is you must have seen some initial announcements that have come up specifically in the US on 5G based fixed wireless access. This is a very disruptive technology if you kind of think about it. Today, at home or in enterprises, when we rely upon, when we want to have some kind of good connectivity, we, imagine a residence. We rely upon cable services. So there's a person who actually probably has dug up cable fiber or probably coax cable that actually comes into your home. There's some good download speeds that you can get. The upload speeds are still pretty weak, but there's some good download speeds. But what if you can get exactly the same thing using, there's a small unit that's mounted outdoors. It's an outdoor unit outside the house or outside the apartment. And it's just connected to the closest cell tower using 5G millimeter wave. You can get gigabit speeds, symmetric, download and upload, gigabit speeds all the way to the home. You can actually do exactly the same thing, not just in dense urban areas. You can do that in suburban and rural areas as well. And this is a very good technology to actually to think in terms of how you can actually not necessarily rely just upon fiber, but it's a replacement for fiber. It's a low-cost deployment model. Why? Because mobile operators are anyway deploying these cell sites. They're serving the regular consumers on their smartphones and whatnot. Well, you can use the same cell sites to actually cover the residences as well. Very disruptive technology as it so happens. As we talk about that fixed wireless, I want to get to the, what are the other things that it does. We recently, as Qualcomm, we just recently did a specific demo in rural Wisconsin. It was nice, actually, right in the midst of soybean fields on one side and corn fields on the other, but right in the middle of that, you have a cell site that was like 5 kilometers away, and we could get 100 megabits per second in a rural area in Wisconsin. And you might be thinking, well, 100 megabits per second is not exactly gigabits per second, but here's the thing. Today, using 4G in the same location, you'd be lucky to get like 5 megabits per second or something because the coverage is not very good. So this is a huge improvement. One question then is, if we can get to these hundreds of megabits per second, perhaps gigabit speeds in rural areas, what can we do there? Well, here's an example. Actually, some of this even started with this pandemic that we have now. A lot of the students are really, such as yourselves too, are really relying upon online and distance-based learning mechanisms. At some level, I would still argue that it is, it's like a streaming in a certain way, but it's basically an extended version of a video call, right? But what if, using these extremely high data rates, we make learning into a truly immersive experience, interactive learning? The teachers are probably located in a completely different location. You're in a different location, but the quality of teachers is no longer a function of where the geography is or where the school is located. So in rural areas, you might not have good quality teachers. That's okay, because the quality teachers might be located elsewhere, but you can still learn wherever. And that way we can actually truly bridge this digital divide between the urban, suburban areas on one side and the rural areas on the other side. We can bring in distance learning, can become mainstream in some of these areas, and you have good quality education coming into that. This level of access to high quality teaching and content, we believe is going to be quite important as we move forwards. There's a bunch of things that actually come into that. I just talked about the immersive XR learning experience, wherein you put on an XR headset. XR is just a combination of, well, both augmented reality and virtual reality, but if you put on a headset, you can do things with it wherein you feel like you are in a classroom in person, but so are all the other students along with the teacher over there. This is one, it's not a futuristic use case, it used to be, but it's gradually becoming mainstream. We have work to do, but that is one way of actually getting there. Another one is an interesting one with telemedicine. In fact, this I thought was going to be a more futuristic use case, but things actually happened pretty rapidly right after this pandemic when it started, when Patients can no longer just walk into a hospital or to a clinic, but rather you have the healthcare professionals looking at telemedicine-based mechanisms to first do some initial triaging. That was the starting point. But it's no longer just about initial triage. You have a situation wherein healthcare professionals can access medical data from multiple locations. They can do real-time diagnosis based upon the data that they're receiving. And the real-time diagnosis also happens because you have low latency fabric behind. You can actually get all the data that is needed from a doctor's perspective. You can get that in a pretty fast and efficient manner. So one of the things is when you rely upon something of this sort, I keep wondering whether we'll ever go back to where it was. I do not believe so, because this sort of a telemedicine is here to stay. But the key to make this work is to have a capable and reliable connectivity all the time. We can't afford to not have the connectivity because that's now the backbone for telemedicine in general. Here's an example of a factory floor. By the way, for a long time actually, I never really went into factory floors. But a few years back, for the first time when we were thinking about 5G transforming factories, I would actually spend some time and understand. Tell me how. We spent time talking to manufacturing plant owners and saying, how do you define your operational efficiency today, and what can we do to improve it? Well, one of the things that comes up is that today's a modern day factory is a fascinating place where you have there's tons of wiring all over the place. There's lots of data that's getting collected, lots of wiring, and you have to actually reconfigure a manufacturing plant. You have to like kind of stop the production, then move things around, and then there's a downtime associated with that, and then you bring it up again. You got to calibrate, bring it up again. Uh, there's efficiency loss associated with that. But if you have everything, that's because you're kind of unplugging wires and plugging wires again and so on. But from a purely, if you have a wireless technology inside the manufacturing plant, then the overall downtime associated with the reconfiguration is significantly lower. All of a sudden, you can actually improve the operational efficiency of that plant significantly. That's pretty big. The second thing is, while an object is getting manufactured, while a product is actually getting manufactured out there, you're collecting analytics all the time as it's going through the assembly line. In some sense, you're doing not just on-demand quality analysis, but you're actually proactively looking at it so that you don't wait for the product to be completed at the end of the assembly line and then do the inspection. And by the way, if you find a problem, then it's very expensive because you can't actually fix it and you might have to discard it. But if you catch the problem early on, then you can actually turn it around and make sure that you have very few losses at the end. And that's enabled because of what's known as edge analytics. You're constantly collecting data from the device. So there's a 5G module which is in the device as it is getting a 5G module that's associated with the object as it is getting manufactured, and you actually collect the analytics from there. Pretty fascinating. One of the things that you need, by the way, for this high precision manufacturing and so on is this notion of ultra reliable and low latency communication. They're not necessarily, they don't always go hand in hand, but in this case, you're trying to replace a wire and you want to have ultra reliability along with the low latency that's needed with that. And that's possible with 5G. Another example is as we were actually building up 5G technology and looking at what it can do, from Qualcomm, we do a lot of testing in-house as well. And so this is actually a picture of our building where we said initially what started off as a thought experiment, but eventually translated into let's actually try it out and see what happens. We have access points, Wi-Fi access points all over the place. Well, what if we augment those access points with 5G millimeter wave technology? So this is like a pretty dense, typical office environment. Bunch of Wi-Fi access points all over the place. When we did this and we looked at the overall performance and we co-sited this, this is like a heat map of what the office environment looks like. We ended up with the median data rate. 50% of the area, you get 5 gigabits per second download. It's mind-boggling to get this kind of a capacity and a user experience. Now, 5 gigabits per second is not needed on your laptop to just do email. You can do a lot more now. all those collaborative workplace environment that I mentioned, the kinds of concepts that I mentioned, they easily apply when you have this kind of high capacity and high individual user experience that you can have inside an enterprise building. So it's quite something. So now when you now think of how should a meeting really look like, this is an example of that. Not only do you have, of course, 4K streaming all the time, but there's a bunch of other things. Of course, this is, as Qualcomm, we try to put together what it really ought to look like. But this is one way of doing it, where you have people, video streaming all the time, but slides are being presented. There's folders that are getting dragged back and forth. There's like recall of notes from the previous meeting. You're pulling assets, by the way. They're not necessarily located, all the files and so on, all the different assets. They're not necessarily located on your laptop. They're actually all in the cloud. And that's the thing that 5G gets. If all your data is in the cloud, and you're just using your laptop as just a client, a thin client with which you're noticing something, what you need is a very high speed, low latency tether, 5G, that connects you to the cloud. That way you don't even feel like the data is really in the cloud. It feels like it's actually all the time on your laptop, but you can just go from one device to the other and access that at any point in time. So one final note is, as we were doing this, we actually came up with the concept of even real-time translation, because that's doable. You can have different teams in different geographical locations speaking different languages, and yet with real-time translation, we can have a meeting that can look like this. Looking forward to a meeting something that looks like this. This is our vision of how things could be with 5G. Now, one final note before I sign off, and then we can talk about all the different questions that come in. 5G, as it got deployed last year, we are in year 2 of 5G, relied upon 4G as an anchor and adding in 5G services on top of it. What's called a standalone 5G is, well, we don't worry about 4G anymore. It's purely 5G at this point in time, but it brings in a lot more capabilities into the picture. It's far more secure. There are new secure capabilities that are put in. Of course, people can keep adding layers and layers of security on top. Security is going to be important. If 5G is truly a technology that's going to go into all kinds of different industries, tomorrow we could be talking of 5G based electricity grid or the national water grid. You want that to be ultra secure at that point in time as you're monitoring the situation across the entire country. And so security is paramount in that sense. Network slicing is a concept that really allows you to have different kinds of users, devices, and services have very different needs. Some of them might be fixated on just very high data rates. Some of them don't care about data rates. It's all about latency and reliability. And in other instances, maybe you're actually talking about a water meter or a gas meter, in which case it's more about capacity than latency and reliability. One way of looking at all of this is these are all considered as different slices of 5G. That's what is meant by network slicing, a concept that comes in with 5G standalone mode services. So these are new capabilities for very different kinds of business models. We, as Qualcomm, had commissioned a specific study. It was called as the 5G economy. This was about a year back, just around a year back, actually. And we published it about last year, saying, if you kind of think about the transformation that 5G can bring to these different industries, how do we measure the overall impact? Now, there are several ways of measuring it. This was a specific way of doing it in terms of 5G-enabled goods and services from all kinds of services, ranging from retail through healthcare to energy, transportation, what have you. And the final number is probably the specifics of the number, $13 trillion, is the overall economic impact worldwide, is probably not as important as the scale of that. It is a huge impact. So as you think into what kind of businesses that you go into and the businesses that eventually get transformed, it's important to keep in mind that 5G as an operational tool has a huge potential to transform that specific sector. And some of this is already in the works and happening as we speak. So keep that disruptive potential of 5G in mind as these sectors actually come into your picture. So I'd like to stop now and really spend the time on Q&A, but thanks for having me give this talk.
Great. Durga, a big thank you. I'm Terry Kramer, Faculty Director at the Easton Center, and I'll be leading for the next few minutes a Q&A with you. What a fascinating conversation about this expansive nature of 5G and what it can do. Let me start out on the first question here. It sounds like a lot of things have to happen together in a broader ecosystem to realize all these benefits. I assume in relation to content and infrastructure and devices, et cetera, et cetera. Give us your mental map about what needs to happen to see this kind of vision come true.
Okay. So I would actually, there's like three distinct elements at play when it comes to 5G over here. First, within the traditional telecom industry. So when you start thinking of device OEMs, infrastructure players, service providers, in some sense, actually, we know each other very well. We speak the same language. We've been doing that for the past few generations. That part, yeah, we all have the right vision. We know what needs to be done. However, it's not enough. It's important for that. And the reason for that is 5G as a technology has to go into these new industries. And so we need to have that conversation with the manufacturing plant owners, with mining sector, with enterprises. And we started this exercise a few years back, taking requirements from there. That dialogue has begun. I would still argue that we've come a long way from where we started, 5-6 years back when we first started talking to whether it's automobile manufacturers to those who are really in the business of factory automation and so on. But probably we are at the point where we are still talking to, maybe the top 10% of that industry. There's like a large number of other players who are just beginning to understand perhaps 5G is of use to them. So that's a work in progress. So that's something that's happening. At the same time, I also want to mention something else. Because 5G is so expansive in its reach, there is a role for regulators and policymakers as well. Because if you're a policymaker in DC and you're thinking about, okay, if this was a technology that was just going to consumers, that's one thing. But if this is a technology that's going to be eventually used, as I just gave an example of, maybe it's for the national electricity grid, then what does it mean for me? What kind of a policy do I need to have in mind? What sort of incentives needs to be in place and so on? So there are three different set of people who are working right now. There's work being done as we speak, but we are just beginning on this in terms of it's a 10-year journey. But a lot of this is going to happen over the next few years as we see the initial pilots.
Yeah. And Durga, what breaks any log jams as you're trying to move into these different sectors, agriculture, healthcare, entertainment? What exactly needs to happen? Are the use cases still needing to get fine-tuned where they get really exciting? Is there more infrastructure deployment that needs to happen? Is there more app development? But what keeps you from being in a situation where everybody's waiting for one another and meanwhile the kind of clock is rolling and things aren't getting deployed?
So I will start with from the deployment standpoint. There's actually a big transition that's occurring on the infrastructure side as well. So devices, you can already see that 5G based laptops, 5G based CPEs, 5G based industrial robots. Actually, we already have 4G based industrial robots. You can see that in AGVs, cameras, surveillance cameras. So a lot of that on the device space, it's been a very rich area, and those things are coming up. But in infrastructure, there's also a transformation where there's a lot of emphasis on disaggregation of different elements, because you can't take an existing telco, for a typical smartphone-based network and try to retrofit that into a small manufacturing plant. So that scalable architecture of the network, there's work going on in that space. As Qualcomm, we are doing our part as well. We just made an announcement last week on how we are providing solutions and platforms for others to build infrastructure in that space. But in finally, the use cases, I would argue that, from as Qualcomm or a lot of us from a telco perspective, our job is actually to build that platform and have faith in the rest of the sector to come up with the use cases. I'm not going to go and predict all the kinds of use cases that are going to be, but evangelizing the technology and talking about the capabilities of that, the rest will happen. I'll give one simple example. When we first talked of position location in our phones, it was supposed to be for 911 emergency. You make a phone call, first responders need to know where you are. I don't think anyone thought that, oh, one day Uber might show up and actually use that to build a completely different kind of a service. So from my perspective, I just have faith that the use cases will come in as more and more people understand this.
Yep. And as a leader in this area, if you look forward and say, here are the metrics or the barometers that I use to say that the deployment of 5G is happening, what would you look at? Are you looking at number of users? Are you looking at site deployment? What are you looking at to kind of say we're on pace here?
I think it's a combination of number of users and the overall, nationwide coverage that you see, along with the kinds of data rates that you expect with 5G, right? You got to be able to tell that it is quite distinct from what I see in 4G, and more importantly, I see this more frequently, not just in a specific area, but everywhere. And we are beginning to see that. It's still gradual pace, but we are beginning to see that.
Excellent. Let me start taking some of the student questions from Slido, and there are quite a few here, and I'm going to try and aggregate a couple of these into a broader theme. So there's a set of questions that have to do with health and safety risks, 5G and in the home certainly, but even in communities. And let me aggregate it because there's some questions about China actually, and a lot of kind of comments that China is outpacing the US because zoning hasn't been as problematic, et cetera. Give us your broad view about health and safety, China's model. Are we getting too wrapped around an axle on these issues, or no, this is the right stuff, and China, be careful?
I have from a purely keeping all the geopolitics and everything else aside, if you just focus on the technology portion of it, here's my view. One question that comes up is, as US, are we actually falling behind on something? Actually, I have a very different view because it depends upon what is the metric that you're using. For example, if the metric were technology, the US is the first place where we launched millimeter wave. It's a brand new technology, huge potential for so many different services. Most people didn't even believe that it would work. 5 years back, nobody thought it would work. And today we all buy our smartphones with it. And it's the only country where we have, both the below 6 gigahertz and millimeter wave technologies deployed today in the field. That's the US viewpoint. If you now take a look at China, on the other hand, what China did was they went for scale. It's the largest deployment of its kind today in 5G. Mm-hmm. So it depends upon the metric that you're using. From a technology standpoint, I would argue that US deployments have led the world. From a pure scale standpoint, like number of users, number of cities and coverage, I would argue that China has led the thing. And that's where things are today. We are still in the early stages of 5G, right? And now we are beginning to see, okay, now the US is going to be going into the scale as well. And over time, China will bring in the technology. Time will tell exactly how that progresses. So I have a very different viewpoint in that sense. Now, let me come back to that point of, okay, zoning and so on. Actually, maybe that's not the right way of looking at it. Because in the end, when we think about the kinds of, if you really want to have a 5G network, which is going to be on, indoor enterprises and stadiums, on top of traffic lights, inside malls and all sorts of other hotspots, you have a combination of these large towers and macro cells and what goes all the way down into small cells. And I believe we've done quite well in that space. Of course, there's still work to be done, but I think that we've taken the right approach from our side. So I'm optimistic about it.
Okay, good. And let me ask you just one other question on China versus the US, and that's the US historically has had a more individualized, laissez-faire, environment. And some people say that's great. That's how Qualcomm, it was originated. Some people will say the standards environment in China has allowed for greater acceleration and, tapping data and other things, and maybe even throw India in now with geo and a very rapid deployment. Give us your broad view about these environments. If you had to kind of say, what is a perfect environment for standards versus entrepreneurship versus size of company, et cetera, where would you come out on that?
So as Qualcomm, we believe that, okay, as we work towards it, actually, it's probably one of the best ways of making sure that the right technology comes out as well. So we truly believe in that entrepreneur model that you mentioned. But at the same time, keep in mind that multiple companies do come together and there is a standardization process. 5G went through a standardization process through 3GPP, just like 4G before that, just like 3G before that. So there is a forum where after you're done with all of your initial R&D and prototyping and inventions, you come together and say, okay, you got the spirit of the technology in place, but now let's go through it's not just the concepts by themselves, but you have to write it into actual specifications. The letter of the spec matters as well. That standardization process is a global process. It's so many different companies from everyone comes in. We strongly believe in that as Qualcomm, and in general a large number of companies in the US believe in that sort of a standardization process, because then we all have the same playbook to build products. Otherwise it's too fragmented, so you need something common to build products on top of it. But the source of that standard, the source of the technology of that is really coming in from different companies, and we certainly have our contribution towards that.
Excellent, excellent. Next set of questions has to do with security. So, you described the network as a very interesting way, that the connectivity fabric for everything. And I assume there'll be billions and billions of devices, Internet of Things, cars, homes, our bodies, everything. Tell us about the security risk here, all of the dystopian things we hear about. Every point that there's connectivity is a point of breach that could hurt the nation, can hurt companies, individuals. Tell us your view about security.
Sure. So there is a portion of the security which actually there's been an improvement going from 3G to 4G and 4G to 5G. So as a standard, as a technology, 5G has its own security framework in place. There's something called as ciphering, there's something called as integrity check, there are multiple layers of that. I mean, in the end, for example, your SIM card contains a lot of your credentials. It's not like in contrast with Wi-Fi where you enter a password and that's it. The password is verbal. It's not something that's embedded in a module like that, right? So 5G has the security credentials in place. What you're referring to is the kind of security wherein how do you make sure that it is tamper-proof? And how do you make sure that are these hardened credentials or are these software credentials? If there are hardened credentials, where is the source of that? Who actually gets access to that? That's a different kind of an argument in itself. I think some of it even goes into, well, if I really want a secure network, I want to have like absolute control, everything from the technology to the supply chain to maybe I add my own secret sauce on top of it and create a walled garden. That's a possibility, and that's one way of doing it. But there are ways of addressing the security concerns. I think that's the way that I would actually think about it. It's no different from a lot of other things that we do. With increased security, you want to have additional safeguards on top of it. That's the way that we would do it.
Excellent. Excellent. There's several questions about the fixed wireless applications you're talking about. Tell us more about when we practically will see that broadly deployed. And is this something that will transform the high-speed internet we have today in our home? Massively lower cost, higher speed, less digital divide. Is it of that magnitude, or that's 50 years away?
Actually, one of the major operators has already deployed it in few cities. I'm looking forward to it in San Diego. I know that it's been deployed in some places. But no, it's actually happening as we speak. The question is more about the rollout cadence, how many sites in different cities and so on, but it is happening as we speak. And my understanding is that it's a service that can be coupled with your mobile services. It can be decoupled from it, but I'm really looking forward to that, because if you take a look at today's cable speeds, we have very high download but low upload, but this one actually gives you symmetric links, much needed in these times.
Excellent. Let me ask you a couple last questions here before we get to a wrap up. Give us a scalar on the transition as you look to 3G to 4G transition, 4G to 5G, and maybe what will be 5G to 6G. How big a transition is it from a cost and complexity standpoint?
Let me put it this way. 10 years back, December of 2010 is when I believe Verizon launched 4G. I remember that because I was, I think, the second guy in the store who bought a device there. I wasn't the first one. But back then, it was like one or two operators, there were like one or two device makers, and that's pretty much it. And the rollout was gradual across the world. It took about 2 years for every country to come in. The 4G to 5G transition is completely different. It was as if every single operator, every single region wanted to deploy 5G at the same time. And just by the end of the first year of deployments, we are seeing these 200 million people who already have the devices, 200 million handsets that are getting shipped. Nothing close to this when we did the 3G to 4G transition. So it's a big change in that sense. So the pace at which things are happening is really big, and I look forward to it as new services are coming up.
Excellent. Excellent. Let me do a quick wrap up on the points that I heard, and then I'm going to turn it back over to Jordan and Mandar for some closing comments. I got several takeaways from you today, which are fascinating. The first idea here is that it's this connectivity fabric for everything, that 5G isn't just for smartphones. This is a very kind of broad set of applications that includes consumer and enterprise and homes and offices, et cetera. A second main point that I took away is that there are a lot of differing applications. I mean, I was amazed at the breadth of applications here. So the collaborative workplace, connected vehicles, fixed wireless, multiplayer gaming, remote learning, et cetera. This has got a fairly broad aperture in terms of opportunities. A related point is we all tend to default to consumer applications, but there is a very heavy enterprise play here where you can find some very good use cases and maybe even quicker adoption potentially. A couple last points I took away is the benefits to society actually can be quite notable here. Education and healthcare, this remote education that you talked about could transform and improve quality of education while reducing cost. Same thing potentially in healthcare. And then the final kind of thought, and maybe for a lot of kind of business leaders, is manage the ecosystem, that you've got to manage all the different players, make sure you've got kind of alignment, that there's already some good momentum 4G to 5G, but you've got to make sure you're thoughtful to make sure this thing kind of plays out in the time and scale that you want.
Yep.
Any upgrades on those takeaways?
No, I think you captured it very well, and that's the gist of how one should actually look at 5G. As I said before, it's an operational technology and truly a platform for the future. That's the way to look at it.
Outstanding, outstanding. Well, let me thank you. And then I want to turn it over to Mandar and Jordan. I have learned a massive amount. As you know, I'm a telecom guy by my background, and I learned a huge amount. So a big thank you for that. And let me turn it back to Jordan and Mandar.
Thanks, Dave.
Durga, thank you so much for coming and giving us this talk. I wanted to expand really quickly on the student perspective from what some of the things that Terry was saying. And as people entering the workforce out of business school, I think one of my biggest takeaways from your talk was that this idea of having a collaborative effort to launch a technology like this. We think a lot as students is what products do we want to work on? How specific do we want to be? But to be an effective leader in this space, it requires that technical knowledge and the product knowledge, but it also requires the ability to cross-functionally communicate and work with the wide range of not only other companies that need to be involved in this from an infrastructure side and application side, but also the regulatory side. You need to be able to speak from a leadership point of view and work with all these people for it to be effective and an effective launch. And so that's something that I will definitely be taking away and think about as I think about the future of my career. And I I pose to the rest of my classmates to think about how they're going to leverage their specific product knowledge into something that allows them to collaborate with other lines in the value chain to make sure that deployment actually works. So I thank you for that. Thank you for the talk. I want to take a second here and also thank your team, Connor and Jill. They were great in helping us manage this conversation. And I also want to thank Mandar for organizing the origination of this and really pushing us to get you on here. It was a fantastic talk, and I thank you very much. And I'll give you a few minutes here if you want to make any closing comments, but I'm sure everybody enjoyed the conversation, and we look forward to learning more.
No, nothing more to add, but really it was a pleasure actually giving this talk, and hopefully you took away something from this that will be helpful in your career as you look forward to it. So all the best in the future, but thanks for having me.
Of course, thank you so much for all those still on the call. We'll be sending out follow-up materials shortly, and we really appreciate you taking the time to attend, and thank you all very much.
All right, thank you. Bye.
Good. Thank you.